everybody, it's Miss Austin. I'm going to be going over the lesson 4 practice problems. Number 1, here are two expressions whose product is a new expression A. Andre says that any real number can go into either of the boxes and A will be a polynomial. Is he correct? In order to be a polynomial, you have to have non-negative exponents. So we could not let this guy will have an impact on whether or not it's a polynomial. This first box can be anything you want. The numbers in front of the variables can be positive, negative, whole numbers, fractions. But this second box, right, if we let that anything smaller than -3, that's going to turn that one into a negative, right? Imagine if that was a -4. When I multiply those two together, that's going to become x to the negative first power because you add the exponents. Let's just say I put a 2 here. That would become 8x to the -1. And right now, I have just created something that is not a polynomial. So I need the second box to be greater than -3. -3 would be okay because that would turn that into 0, and x to the 0 was just 1. So the second box has to be -3. You can't have negative exponents. That's not a polynomial. I mean, you can have negative exponents, but it wouldn't be considered a polynomial, which is what Andre claimed. Number 2, Lynn divides the polynomial 2x squared minus 4x plus 1 by 4 and gets 0.5x squared minus x plus 0.25. Is that a polynomial? Yes. As long as you have non-negative whole integer exponents, you're okay. It doesn't matter about the numbers in front. You can have decimals. You can have negatives. Yes. All non-negative integer exponents. All right, we're looking at the exponents. That's a 2, and that's a 1. We're all good. Number 3, what is the result when any two integers are multiplied? So they don't put any stipulation on what kind of integers are. Integers are your positive and negative whole numbers. So -3, -2, -1, 0, 1, 2, 3. So when I multiply any two of those, am I going to necessarily get a positive? Not necessarily. Am I going to get a negative? Not necessarily. Am I going to get another integer if I take a whole number times another whole number? Yes. Even? Not necessarily, right? But for sure, I'm going to get an integer. I'm not going to be able to get a half or a decimal. Number 4, Claire wants to make an open top box by cutting out the corners of a 30 by 25. Here's that problem. Cutting out the corners from lesson 1, 30 by 25. And you're taking away 2 cuts from each of these dimensions. So and then you fold it up. And I think I might have thrown it in the garbage. I shouldn't have. Well, Miss Austin, I thought I saved it, but I don't know where it is. So to find the volume, you're going to take the length, which is whichever one you want to call the length, 30, take away 2 of these x's, times the width, which is 25, take away 2 of the x's, and then the sides, x, become the cutout. That's the height. You can put the x wherever you want. I'm just going to put it in front. That's how you write the volume. That's the height, length, times width. What is a reasonable domain? Meaning, how big can you make these cuts in this particular problem? Well, you want to look at the smallest dimension, which is 25, right? You're taking away 2 of these cuts. At what point would that be gone and there would be no paper left? Well, just figure out what's half of 25, 12 and a half. If each of these was 12 and a half, that'd be 25. 25 take away 25, the paper would be gone. So we're just going to give kind of our upper and our lower bound. We know that the cuts need to be bigger than 0, but smaller than 12 and a half. So put your X in the middle. We want them bigger than 0, but less than 12 and a half. How did I do that? I just looked at the smallest dimension and cut it in half. Because if I take 2 of those and subtract from there, the paper there wouldn't be anything left to cut. Number 5. Identify the degree, the leading coefficient, and the constant. I'm going to make a little chart here. Degree, leading coefficient, and the constant. So we've got that one and that one. So the degree is the highest exponent in the polynomial. So this one you can see is the 5th degree. The leading coefficient is the number in front of the term that has the highest power. Now this one, it doesn't necessarily have to be in order. This one is, look, it goes 5, 2, 1, and then no power. So that's your line leader right there, 2. Constant is the number with no variable, -6. Next one, what's the degree? The highest power is 3. What's the number in front of the term with the highest power? Well, there's nothing there, but there's a 1 there, right? Ninja 1. And your constant is your number without your variable, 2. All right, look. See, they tried to be sneaky. They didn't put it in order. The highest power is right here, 3. It's a 3rd degree. And if you want, you could rewrite it like this. I just put it in order. Highest power, 3, 2, 1, none. And the reason I want to look at it like that, because that's your leading coefficient. Your leading coefficient is the number in front of the highest powered term. And then the constant is 5.4. The reason we are practicing all this is because these are going to tell us some important things about a polynomial in the future. Which point is a relative min? That's the absolute min right there, right? Which they don't even put a point on, because that's the absolute, that is the minimum. Well, maybe not, Miss Austin. If there's an arrow, that actually goes even further, but there's no point on that. So which is B a relative min? No, that point's lower than that. Is C? No. D? No. A, that's lower than the other points around it. All right, guys, that's a wrap. I hope that helped, and I'll see you soon. Bye-bye.